the things about growing king prawns in the UK obviously is the prawns like it hot, and most of the time the UK is not warm enough for them. So insulating our building was something that was really important to us, and we use this stuff, which is basically a duvet or fleece made out of single-use plastic drinks bottles, and that keeps the whole building really toasty. So we've got this winter we had snow on the roof. It was about -7 degrees out here, and it was 32 degrees inside the tunnel, and it was a very nice place to be. And you can see the concrete pad next to me. This is going to be a mounting point for a solar gazebo about 30 meters long, and we're going to put some more solar panels on it. With winter coming along, the sunlight's becoming a bit weaker, so we need a few more solar panels to run the building, and that'll be happening over the next couple of weeks.
So Andrew, what are we seeing here? What's here in the R&D section?
So you're basically seeing a duplicate R&D system where we have the same number of tanks to my left and to my right with the same filters, so it's all identical. And what we did here was we looked to try and understand what the shrimp want and what's best for them. Absolutely, yeah, not all shrimp want the same thing. It's down to the genetics of the animal, so where the animal comes from effectively, which hatchery grew it. Shrimp have been grown in captivity now for quite some years, and their genetics is very different depending on their source. And they're grown in ponds usually. So one of the things about pond growth is you're kind of stuck with the temperature you get, you're stuck with the daylight that you get, and the weather, the rain levels, the salinity levels. Whereas when you're growing them indoors, you have choices. We can set the parameters to what we want, but what we didn't know was what were the best parameters to start with. So we've spent the last couple of years working out what the right temperature is, the right salinity, right pH, correct feeding, and all the rest of it. And that's why this little facility was really useful, and it's paved the way for us going into a bigger facility, effectively knowing what we're doing.
And where are these shrimp from?
These particular shrimp are from the United States. So we bring them in from America as PL12s, and we grow them here. So effectively we're fattening them. Our aspiration next year is to stop doing that and instead concentrate on breeding them here in the UK. I mean, it's a good question. One of the unusual things we do here is we don't just dump the water back into the sea or into a river. And instead, what we try and do is clean the water up and reuse it. So we remove all of the solid waste from the water and we anaerobically digest those. And we take the liquid waste and we grow crops in it. Now, one of the things about shrimp is the water is salty, so you can't grow normal crops. Instead, we concentrate on things that quite like salt, like seaweeds and the samphire that you see next to me. This is a sort of succulent, and bizarrely, it's actually used quite a lot as a garnish for seafood, which works really well, seeing as we grow seafood. So these guys take all of the nutrients out of the water, and that means that we can reuse the water again rather than throwing it away. Yes, so this is the Eaton estuary behind me. It's a site of special scientific interest. And just over here we've got the old Guardbridge paper mill, which the university bought a few years ago, and they're redeveloping it now into an innovation space and for lots of other uses. And the North Sea is basically over here to my right, and the water behind me, bizarrely, is too dirty for us to grow our shrimps in. So we can't use the water out of the sea behind me directly, which is a little bit strange. From the sea, we have to purify it, and bizarrely, when we put the water back that we borrowed, it's cleaner than it was when we borrowed it, which is something that I'm really both proud of and deeply disappointed about. There's no way that the water in the sea should be too dirty for these animals, but it is. So what we're looking at now is the next iteration from those little tiny research and development tanks. We've effectively figured out what we're doing in the little tiny tanks, and now it's time to move into something a little bit larger. So over my shoulder here is a 23,000 litre tank, and the R&D tanks were only 1,000 litres, so it's quite a jump up in size. And you'll also notice the tank I'm sitting on is made from concrete. So this is a low carbon concrete. It's actually slightly carbon negative. And the reason for the concrete is it's an enormous thermal mass, and that enables us to keep a much more even temperature than in the plastic tanks that we're using next door. And our animals are getting ready to move into here in the next month. At the moment, we're leaching all the chemicals out of the paintwork just to make sure that the animals are kept nice and clean and pure. So there are no animals in the tanks behind me right now. There were the animals that we saw next door. They're coming in here when they grow up a little bit. Yeah, so behind me here is about 150 tons of wood chips. And our landlords, the University of St Andrews, use these in a biomass boiler. And they pump the heat up the road to heat all the university buildings in St Andrews. And one of the byproducts of doing this is carbon dioxide, which we capture, and we use it as an alkalinity supplement in our farms. So that way we're circularizing somebody else's waste and using it for something that benefits us. Yeah, this is a solar farm that we use to power our shrimp farm. All the energy that we use on site, we try and make it as sustainable as possible. And one of those things that is quite a benefit is to have access to electricity that's not generated using fossil fuels. And believe it or not, Scotland in this particular area is quite sunny. So solar power here is not as ridiculous as it may at first seem.